Yeah, can you hear me? Is my voice audible? My screen visible to you? Everything's fine, right?
Yes, sir. Yes, sir.
Okay. So I'll start with week 11. Okay. So mostly in week 11, we are starting with some concepts like whether mostly from a signal we have to we are, how can we use a signal itself directly. Okay, you would have read about a different type of a signal in many of your courses in electronics or maybe in signal system and all. So here we just have to use how can we use whether we can use the signal as a vector or not. So the first method that we are doing here is I'm not going into that much detail. I'll just give you an idea, brief idea, and cover all the things, and also maybe we'll solve some problem that may help you in the exam. Okay, so from a signal, so the first concept that we are dealing is, can we use the signal directly? Signal to the vector. So what are we doing? We have been given any type of a signal can be there, any signal, and then what we are doing with the help of sampling. If we'll do the sampling, we can have. If we'll do sampling of any of the signal that is there, signal can be in the form where the independent variable will be t and the dependent will be xt. If we are doing the sampling of this, we'll be having some sort of a this we can convert into a form of a vector. Okay, the time interval we can manage, but I'm just giving an idea. If we are just sampling it, we can have a vector. Okay, that can have a n number of values, right? We can put it in the form of an interval or maybe a 0 to infinite, whatever, but we'll be having a vector. Okay, and this vector that we are getting from the signal, okay, so this signal can be used as a vector. Why? Because it will satisfy all the requirement that should be there for a vector. Like the addition, there are three requirement, right? So if we have any vector, any signal that we are converting to a form of a vector, okay, so it will satisfy all the three condition that is there: vector addition, or the scalar multiplication, or the third one is the zero vector. Okay, and whenever you are doing this type of thing, okay, so the span of this generally is called as a sequence space, right? Have you gone through the lectures, right? So these are called as sequence space, right?
Yes, sir.
Correct.
So,
And
yeah.
whenever we are directly using the signal itself as a vector, so that will also satisfy the three all the three conditions. So here what you are doing, here you are just doing the sampling and then having a some sort of a vector. Okay, so you are converting that signal into some sort of a vector. Here you are directly, can we use that signal itself directly as a vector? This also, so let's for example xt is one signal, so this will also satisfy all the condition. So xt plus yt will also belongs to some sort of a signal itself, and then we'll be having the scaling. If you are doing the scaling also, that will also satisfy. And then the third, you can have a signal that will be zero for all the t. Okay, for all t, right? For all t, correct. So here also, and this type, if we'll take the span of the signal, will be generally you call it as a what, function space, right? So here you call it as a sequence space, and here you call it as a vector space, function space, right? Correct. So
Yeah.
here in this type of problem itself, you can just for a function space, you can fix a domain also. So you can just fix the timing from 0 to t also, right? This also you can do it, right? So now we'll, so there's now we have some important concepts. So this was just a basic idea, like how can you use the signal itself, or you are doing the sampling then. So nobody is going to ask you anything from here. The thing that can be asked is the inner product for a sequence and whether it is converging or not. Okay, so you already know that for an inner product to be satisfied or the inner product to exist, that should converge, right? So if the series should converge for sure. If you are taking the infinite length, okay, so that should converge. If it's not converging, that means the inner product is not defined, okay, for a real part. And if you are dealing with a complex number, then the all both the real part and the complex part should converge. Then only you can say that the inner product is existing, or right. So this was the simple concept. Now the important part starts whenever you deal with the L2. So whenever you have, so the one the most the important part will start from here. So till now it was just the basic things, the terms and all. So nobody will ask regarding that. Like from here you can be asked regarding the questions, like if you're dealing with the sequence space in L2. Okay, what is the condition for that? Can somebody tell me the condition?
It should be norm. It should have norm. So it should basically converge to a finite number, so it belongs to an else. Belongs to L square L2.
Yeah, the L2. Yeah. So that is
Ah,
set of all the sequences that you have. Let's for example, this is the sequence x1, x2, xn, the sequence that can belong to complex or real, such that the real series. So this should satisfy this x1 k square, x2 k square. Okay, this summation should be less than infinite. Okay, so that should converge to some real value. Okay, if this is happening for any sequence of a set of sequence that has been given to you. Okay, if this is holding, okay, this condition is, if this is holding, then you can say that this sequence space is in L2. Correct. Let's for
yes,
example, you can have an example like the sequence 1 1 by 2 1 by 3. Is it belongs to L2 or not? This belongs to L2 or not? If you'll just, how can you check it? 1 k square plus 1 by 2 ka whole square plus 1 by 3 ka whole square, and on and on. Will you get anything if you'll do the summation?
so it converges to a finite number, right?
Yeah, it converges to a finite number. So it will be, this sequence space is what? In L2.
Yeah.
Correct. Similarly, you can any values that is in the form of 1 a square, aq, something like that. Okay, where the a is less than 1. So if we'll do the square of this, 1 k square plus a k square, a square whole square. So this will convert. So this will be less than infinite, where a is less than 1. If a is greater than 1, then it will go to infinite. So that will not be in the L2. But if here the a is less than 1, then this will belongs to a sequence space of L2. I hope this is making sense. Now for a function space. So this for the sequence space. Now for the function space to be, for a function space belongs to L2. Okay, maybe you can fix the time boundary AB. What is the condition? Here also the condition is the integration. So here the integral of from A to B, that should be less than infinite, or that should be having some finite value. If any function space that hold, any function space xt hold this, if it is holding this, where the integration from 0 to A to B of non chi square is less than infinite or having some finite value, then you can say that this xt, this function space is in L2. Okay, right? And there is some formula also. So here you should be knowing about, if you have been given any function space in the form of xt, okay, any signal that has been given to you, and they have just fixed the interval also from A to B. If you have been asked whether it belongs to L2 or not, what will you do? You'll check this condition. Okay, if this is holding this condition, you can directly say that that belongs to L2. And this type of problem is very highly prone to be asked. So you can be given a signal. Okay, any signal can be given to you. It's for example. Okay, I'll give you an example, and then you can be asked whether it belongs to that or not. Okay, so here it was an example. I guess there was a question in a mock, right? So there was a signal given as this xt equals to t. Okay, whether this belongs to L2 or not, from 0 to 1. How will you check this?
Integrate from 0 to 1, and then solve it through the. Uh,
क्या क्या? What did you say?
so, sir, we just have to integrate from 0 to 1, right? and
Yeah,
then
you just correct.
fi- yeah,
You have to integrate from 0 to 1 of what? T square.
yeah.
Okay, and then check the value.
Sir, do we have to take a route after that? No.
No, no, no. Why did you take? No, no. You don't have to take root. So here we are just checking whether this signal that has been given to you, or the function space been given to you, is a function space of L2 or not. This is what you have to check. For that, there is only one condition. Do this like the norm, whatever you have, whatever the function that has been given to you, or the signal that has been given to you, do the square of that, and then integrate in the time interval that has been given. Okay, and if that is a finite value or less than infinite, basically a finite value you are getting, you can directly say that that belongs to L2. Okay,
Sir, could you please solve it because I think I wasn't able to do that. And xt was not t, I think it was t square.
here.
No, I think okay, that is not a question from the mock in that case. It was a question. It was question 2 of 11.4.
Okay, I'll solve that also, but first we'll solve this. Okay,
Yeah.
so this is the question. If you'll just integrate it, what will the value you'll be getting?
1/3, sir.
One, sir.
1 by 3. Correct.
Yeah, yeah. So
So
it
this is a
belongs.
finite value. That means it belongs to a function space of L2. Okay. Now, on the next part that can be asked is, how will you calculate the value of norm square? What is the formula to calculate the norm square? To
Uh,
calculate the norm square, there is some formula, right? Integrated from 0 to 1, xt yt ka bar. Oh, no, no, this is not the formula. I guess the formula for this is pretty simple. So this is the inner.
so for norm, it is just square root of the absolute value.
Uh-huh. Correct, correct. This square root. Yeah, yeah.
Square root of the absolute value.
This is what is norm, and for the inner product you take the conjugate and then
Yeah, yes,
integration.
sir.
Yeah.
Yeah.
So here you just have to do the square. So here the value you'll be getting the same, right? 1 upon 3. This is what we did in the starting also. Xt whatever was given to you, t square ka integration 0 to 1 dt. So here you are getting 1 upon 3, right? So if you have been asked to calculate the norm also for the signal, you can directly calculate it, right? Is it clear?
Yes, sir.
Yeah. You can be given a different here you have been given a different function also. Yt also has been given as something, I guess 1 minus t. So if you'll just check yt belongs to L2 or not, and then you can be asked to calculate the inner product of xt and yt also. So inner product is pretty simple. You just do it xt times yt kabar, right? And from whatever the time interval that has been given to you, 0 to 1. Okay, so this is like t times 1 minus t. Correct, and then you can integrate it, you'll get the value, right? Any doubt here? No, right? Is there any
No,
doubt here? So
no,
two
sir.
formulas, right? So pretty simple. You can be asked to calculate the inner product. For inner product, you can be like whatever the interval that has been given, 0 to t, xt, yt, the bar dt. So this is inner product, and or you can be asked to calculate the norm, right? So the norm you can calculate whatever the norm that you have to calculate, 0 to time interval. Okay, this is simple, right? This is same as like you are just taking the inner product of x and x. If you are taking the inner product of x itself, so this becomes xt ka whole square dt. Done, right? So this was it, like for the basic things. I hope this is the important portion, and for sure there will be a question from here, this topic.
Sir,
Okay.
can you just summarize one more time?
Okay. So what I was trying to say is, till now we were just dealing with a vector n. So here we will start in this week. We are just going through, can we use a signal itself as a vector? Okay, this is what we have to start with. So in the starting, the first method, we try to sample that. So you know how to do the sampling. Like if you have been given a signal, you can just try to sample it. Like you can just take some interval values and then try to hold the values for some time, and then like you can just distribute the whole time interval into some fixed bandwidth. Okay, let's for example 100 bandwidth you have just divided into. Okay, and then you'll keep on whatever the time interval. So basically you do the sampling. I hope sampling you must be knowing from the digital classes. While doing the sampling, you try to, from whatever the time interval that has been given to you, you try to take out that many values. Okay, so for that many t values, you just try to take out the xt, right? So that will work as your vector. Okay, if you'll just keep on increasing the value, let's for example here you are just taking 100 value, now you keep on increasing that value, so in the end you're just tending from a simple vector, whatever you are sampling, that will just start tending to a signal itself. Okay, so this was the concept behind that. So you try to do the sampling, and then while doing the sampling you just came to know that whenever you are doing the sampling of those signal, the vector that you are getting, that can also work as your vector, normal vector that you have done it till now. Okay, because this is satisfying all the three conditions, so that you start calling as the sample, the span of that you start calling as a sequence space. Okay, and the next part was, can we use the signal itself directly? So what, so signal, we came to know that even the signal also we can use it directly. Okay, whatever the signal that has been given to you, xt or yt, okay, that also was satisfying all the condition whatever the vector requires. Okay, and if it is satisfied, so you directly started using the signal itself, and that you call it as a function space, right? Now the concept is, so this was just a basic, nobody is going to ask you anything from there. Now the question will start, they will start asking from here. So you can be given n number of values, like in the form of a, the sampled one, so the signal in the form of a sampled vector. Okay, and then you will be asked whether that sequence space that you got, whether it belongs to L2 or not. This can be asked to you. Okay, so to check that, what are you going to do? Whatever the sequence that has been given, okay, what you will do, just calculate the norm square, okay, for each of the values of your sequence space. Okay, and then do the summation. If you are able to do the summation and able to get a finite value, okay, less than infinite, then you can directly say that the given sequence space belongs to L2. Okay, okay, so this type of problem can be asked. So you can be given a sequence space and can be asked whether it belongs to L2 or not. Okay, similarly, so now we have done with the sequence space. Now for the function space also, you can be given a signal itself, and then you can be asked whether that belongs to the function space of L2 or not. Okay, for that, what are you going to do? You do the integration of whatever the signal that has been given to you, square that, okay, from A to B, whatever the time interval that has been given to you, and that integration, if you are able to integrate and find the value of this, okay, then you can directly say that this given signal is belongs to what, function space of L2. Okay, from A to B, whatever the interval that has been given to you. Okay, now you can be asked regarding, so for the given signal, okay, for the given function xt in the form of a t or 1 minus t, whether you can be asked like whether it belongs to L2 or not, first question, or if it belongs to L2, can you calculate the value of the norm, all the inner product of two vectors. So here two vector was like two signal was given, xt as t and the yt as 1 minus t, and then first question was asked whether it belongs to the function space of L2 or not, both of them. Okay, so for that what did we do, we just took the integration of t square, like because the norm of square, and we have integrated from 0 to 1, and we got the value as 1 upon 3. Okay, so if we are getting some finite value, that means it belongs to L2. Okay, similarly we can check for the yt also. Okay, so we can calculate that. Now they can ask you to calculate the inner product of xt and yt. To calculate the inner product, there is simple formula, xt times yt bar, because it was just, we are just dealing with a real value, so yt bar is yt same. So t times 1 minus t, you just do the integration, whatever the value that you will be getting. Okay, you'll get some values, right? And if, let's for example, this you are getting a 0, then it will be a, this both signal is what, orthogonal. Okay, if you are getting a 0, right, the xt and yt will be orthogonal
Ortho.
if you are getting the inner product as 0. If you are not getting inner product as 0, that means not orthogonal. I hope this is making sense. Okay, or you can be asked to calculate the norm. So the norm formula is this one. This is the norm formula, and this is the inner product. This is the inner product. Where is that? This is the inner product. Okay, clear? Clear to you?
Yes, sir.
Okay.
Excuse me, sir.
Yeah.
In the inner product question, the
Hmm.
part which we just covered, yeah. So it was supposed to be x of t into y of t, the whole bar, or the bar of y of t. So
Hmm.
since y of t is 1 minus t,
Correct.
so oh, would it be 1 plus
No,
t,
no,
or
no. You will take 1 minus t only, right? So bar means what? Whenever you are getting the complex term, there you will change the value, right?
Yeah.
Here you are not getting anything, right?
Oh, okay.
Hmm. So if you would have got something like 1 minus jt, something like that, then you would have did like plus, right?
Yeah, got it.
Okay. So t into 1 minus t, and whatever that you are getting, you can just integrate it from 0 to 1. Okay. Now the next part is the next part that was dealt was about the Fourier series. Okay, and that's the important part. Mostly the polynomial approximation. Okay. So for the polynomial approximation, this concept we have dealt earlier also, right? And the projection in function space. Okay. See this concept we have. I'll just directly come to the result, or if you want, I can just give you a brief idea what we were doing. So we were trying to do something, right? In the starting, when you would have dealt with, like, let's for example, if you are just dealing with some equation x equals to b, right? And let's for example, in the column space of A, if B is not present, and if you have to calculate like the minimum distance between the X and the B, so you were doing something, right? You were taking the projection of something, right? I hope you would have read in the starting weeks. So if in the column space of this A, if B is not present, right? If you have to calculate the distance or something, right? So you were doing something. So you were using some formulas, I guess, right? So where the minimum, you are just minimizing the distance, whatever the from the span of this B and the column space of this A. So the minimum, so the value, you are just trying to find out a vector, or you're trying to find out a vector that is much closer to B, right? This is what you're trying to do in the starting weeks, right? Here also we'll use the same concept. We use the concept same. Will formula also will be same. Okay. I hope this you would have read, right, in the starting weeks, correct?
Yeah. So is it minor axis and major axis stuff?
No, no.
Yeah.
So see, let's for example, uh, so so here you find a closest vector in a subspace of, let's for example, this is a function space L2. Okay, and then you have to find out. So I'll just give. Okay, see what happens if you have L2, let's for example, and you have to find you have to do the approximation of any function that is given. See, any signal you can be given, okay, and then you will be asked, let's for example, a signal that is given to you. Okay, okay, one more thing. I guess Graham Smith method here. Okay, I'll deal with that later. So that you're aware about the formulas and all for the Graham Smith, you're aware. If you have been given a normal vector space, if you have been given a normal basis, how will you get the orthogonal basis, that you are aware of, or should I go through that? That is also left. Before this, you have an idea, like if you have, can you tell me, anyone? Are you aware of that? If you have, let's for example, one second.
Yes, sir.
You're aware of that, right? You can have an
Yes, sir.
input, and then input v1 vk. Okay, these are all the normal. It's not the orthonormal basis for you. You have to get the ortho. Let's for example u1 u2 uk. This you need what? Orthonormal basis. If you need, how will you get? So you already know that there is a method, right? Graham Smith method to calculate that. So how do you get, if let's for example these are the normal vector that you have, so u1 will be what? v1 upon
The
mod of
norm
v1.
will
Correct. So similarly, if you have to calculate the second vector, the second orthogonal vector, how will you calculate? This is how you calculate, right? For the wt, the second one, you take what? From the v2, you subtract that some part, right? You subtract the inner product of
V2
v2
comma
u1, right? The
One.
inner product in the direction of u1, right?
One.
Correct. And the u2 will be what? Will be w2 upon, because this is the second orthogonal vector, but you have to normalize, like make the unit, like the length of unit one also. You have to make the length as one also, so that it will be a, because you have to get a orthonormal vectors, the combination of orthonormal. So this will be the first, this is the second. Similarly, you can get the w3 also. From w3, you have to just subtract it from the v3. So you have v3, right? So here you have the normal vectors that you are trying to make it as a orthonormal basis, right? You were having earlier some vectors, right? Independent nor independent, that doesn't matter. So you're having vector and then you're trying to make it as a orthonormal basis. So from here the w3 will be what? v3 minus, so you will just subtract the other parts from v3 u1 in the direction of u1, and then v3 u2 in the direction of u2, correct? And similarly you can get u3 as w3 upon w3. This is clear to everyone? Yeah. So this was for what? The vector. This similarly you can be asked for the signals also, right? You can be given, let's for example, you can be given like 1 t and t square, tq, something like that. Okay. So these are what? Span of this vector. So you can just treat this as a vector 1, v2, v3, v4. And now you have to get a orthonormal basis. How will you get that? So the same method you will be using. Okay.
Yes, sir.
This is clear, right, to everyone? Is this clear to everyone or not?
Can you please solve this, sir?
Okay. Okay. So let's try to solve this. So span of this will be what? This is the first vector. If you have to get the u1 will be what?
V1 upon norm 1, norm V1. Sorry, V1, just the norm of V1, sir.
Okay, and but we'll have to give something else also because it will go to infinite. So let's fix the time also. Like let's this these are all the signal in L2, and maybe from some time from, let's for example, -1 to 1. Correct?
Yeah.
Yeah.
Yes.
Correct. Now the u1 will be what? v1 upon mod of v1. So this will be 1 upon 1 itself. So this will be 1. Now the second, how will you calculate v2? So let's for example, w2 is what?
V2 into uh, V2 into minus V, this the same formula as we wrote above up there.
Yeah. v2 equals to w2 is v2 minus v2 dot u1 of u1. Or what is the v2? v2 is t, right? T minus dot product of t dot 1. So how do you calculate the dot product? I told you. How do you calculate the dot product? -1 to 1.
X into Y of Y conjugate T. YT conjugate.
xt, if you have to calculate yt, right? Bar. So here yt is what? 1 only. So no problem. -1 to 1. xt is what? T. Correct?
T.
You have to do dt. So what will be the value you'll be getting?
It is T square by 2, and if we substitute 1 and -1, it will be, I guess, 2, sir. Just a minute. That's all.
So it will be t square by 2 -1 to 1. Whatever the value that you'll be getting, you'll be writing here times 1. Correct?
Yes, sir.
I guess this you'll be getting 0.
Yes, sir.
Excuse me, sir.
Okay, okay. One more second. One more second. We have done something mistake. Yeah. So the
Yeah.
yeah.
Norm
the
V1,
correct.
2, sir. 1 by
Yeah,
2.
yeah, yeah. Norm v1 will be
1, sorry, 2.
2. It will be 2. So if you, how do you calculate the norm? What did I say? for any vector, how do you calculate the norm? You integrate it, square this, and then integrate it from -1 to 1. If you'll just see that here it was 1 only, right? For vector v1. For a vector v1 it was 1, right? So if you'll just integrate it, what will you get? T, correct? -1 to 1. So it will be 1 minus of -1. So it will be 2, correct? And this is square of that. v1 ka square of this. So v1 will be what? Root of 2. So here it will be root of 2. Is this clear to everyone or not? Or should I repeat it? Okay. See, I'll just write. So our this was v1, v2, v3, v4. 1 t t square tq. Okay, what we have to do? This is the input, and then we have to get a ortho normal basis, right? So what will start with? What did I say? u1 equals to v1 upon mod of v1. How do you calculate the norm of v1? To calculate the norm, I told you there is two formula. One is for inner product and one for the norm. To calculate the norm, you have to integrate from -1 to 1, because here I told you this L2 belongs to -1 to 1. You have to integrate it. And what do you have to integrate? Norm by square. So v1 norm by square equals to, you'll be getting 1 chi square dt. So this will be what? 1 minus of -1. So this is 2. But v1 will be equals to what? So mod of v1. So the norm will be what? Root of 2. So here u1 will equals to v1 is 1 upon root of 2. Is this clear to everyone or not?
Yeah, sir.
Okay. Now the second part. So you have to calculate what? Now the u2. To calculate u2, first you have u2 is what? W2 upon mod of w2. Correct? First you have to calculate w2. How will you calculate w2? v2, and then you have to subtract those part, inner product of v2 and u1 in the direction of u1. Are there? Okay. Now how will you calculate this? This will be integration of v2, that is t times u1. u1 is what? u1 is 1 upon root 2 dt -1 to 1. What will you get? You'll get 0, right? Because 1 upon root 2, and this is what? T square by 2. If you'll just put -1 1, both will be 0. So it will be 0, correct? So this will become 0. Are you getting me? So this will become v2 minus 0. v2 is what? v2 is t. So this will be t. Now how will you calculate the norm of w2? Because you have to if you have to get the u2, you have to calculate the norm of w2 also. How will you calculate w2, norm of w2? Can somebody tell me? This will be what? Integration of -1 to 1 of
T
what?
square dt.
T square. Yeah, correct. T square dt. So this will be what? tq upon 3. So whatever the value I'll be getting, 1 upon 3 minus of minus 1 upon 3. Are you able to understand this or not? This clear, right? So W2 will be what? If you'll just calculate, U2 is T upon 2 by 3. Clear?
Yes, sir.
Not. So this you got. So this was W2 whole square. So W2. So there's a lot of, like, you can do a mistakes. Yeah. So here it is not 2 by 3. It is under root of 2 by 3. So here it will be under root of 2 by 3. So U2 will become, U2 is root of 3 by 2. So this is that value. An exam also this will be asked, like similar type of a problem can be asked in the exam also. So you can just practice at least 1 or 2 questions. Okay.
Yes,
That'll be
sir.
more than enough. Yeah. So you can just practice 1 or 2 where you are just converting, not this big, but you can be asked like 1 t t square, something like that, and then you can be asked to calculate the orthonormal basis. So this, I guess, and similarly you can calculate W3 also. The same thing, V3 minus, here you'll be doing the dot product twice, right? V3 minus U1 in the U1 direction, then V3 minus, sorry, V2 inner product in the U1 direction. Okay, so this two will be calculating, right? And then the norm of this norm you can calculate. So for norm and for inner product, okay, both you have the formula, use every time, right? You'll be able to get it. Clear to everyone, right?
Yes, sir. Sir, there was this rule also, right? I mean, the dot, the inner product should be zero of all these terms, whatever we have found till now. So, uh, can we
No, no,
just
no, no. It will not be zero always, right? Because why it should be zero always?
I thought this is one of its concept only, because as you said that the
No, no. This vector V3, this is not perpendicular to U1, right?
no, I'm just saying, like, whatever the result we get, just if we want to cross check, so
Okay.
we can just do the inner product of all those terms, and like if we have three terms, v1, v2, and v3, and just to cross check, can we just do the inner product of v1 and then v2, and then v1 with v2, v2 with v3, and v1
Let's
with...
do it. See, this will not be zero. You can just check it.
Acha, yeah.
See, this is what V3 is what, because it was a, see, if this was a even function t square, so that's why you got zero. So here you have what, t square, right? If you'll just integrate it, this will not be zero, right? This will be t cube upon 3. So this will not be zero because it was like order function, right? So you have, because you are integrating from -1 to 1, so this becomes zero because your function was in such a way. So here it was, this was t, right? So if you'll just integrate it from -1 to 1, it will be t square by 2. So this will become zero, but here it will not be zero because it is t cube by 3, right? If you'll just put it -1 to 1, it will not be zero. So this dot product is not zero. Are you getting me?
No,
So
sir.
you just
So
make,
yeah,
okay.
in
You're
the
trying to
final
say something?
answer, we'll get three terms if we have if we have to find the Gram-Smith thing,
Uh,
orthonormalization. So in
for the
the final,
W3, yeah, for
yeah,
W3 you can have. So no, this will be zero, I guess. This is V3, V2 times, yeah, this will be zero because V2 you have already made it zero. So here
no,
you'll be getting
no,
something.
sir. In general, I'm just saying. So whatever the final thing we get, final answer, if we
Huh.
just do the inner product, like we
Okay,
have,
so final answer you want to say this one, U3 W3 upon this one. So this will be like perpendicular to each other because we are making that, right? We are making that orthonormal. So this will be perpendicular to each other. The final thing,
so
yeah, the final answer.
V1 will be perpendicular to V2, V2 will be perpendicular to
No,
V3, and
U1, U2, U3 will be perpendicular to each
yeah,
other.
whatever the final answer is, yeah, basically.
That will be perpendicular because we are making that as a perpendicular, you orthonormal, right? Making
So
that as a
to cross
perpendicular. Yeah.
check, we can just do the inner product, try to multiply it, and if we get the answer to
Okay,
be
okay.
zero,
If that is in the form of options, you can just check it directly.
yeah. So we have options only, sir, in this one.
If you will have the options, you can directly check it. Yeah, that method you can use it.
Okay, okay, okay. Just we have to just multiply those terms and try to find it. Try to find if it comes to zero.
Inner dot product, if you'll just do, if you're getting zero, then you can directly, because that will be, first of all you can check in that way also, the length should be one, or the normal, or the norm should be one. The norm formula you already have, right? That also
Yeah.
you can check, or you can just do the inner dot product. That should also come out to be a zero.
Okay, okay, sir. Got it.
Got it, right?
Yeah.
Hmm. So if you have been given a function like this, t1, t is from -2, whether this is, can somebody tell me whether this belongs to the function space of L2 or not? -2 to 2, function space of L2 or not?
So do we have to find it individually for t and then 1?
No, this is like one function only, right? Minus 2 to 2.
Yes, sir.
That will be right.
Yes, sir.
Yeah. So this type of problem can come. So I hope you are able to solve it. Okay. So I hope so mostly the problem will be from this part. Okay. The remaining part that we have is the approximation part. Okay. Whether the given two functions can be given to like functions can be given to you. Okay. And then you have to find the best degree, like the best approximation. Okay. From the polynomial. Let's for example, I'll just in there also I'll just solve some problem. So in the okay, let me open the slide. So this is done. Yeah. So here it is. So here, let's for example, the example that was discussed by Professor like Andrew sir. He's just discussing right whether one function is given, like one you can just think of as a signal also, or one function as a sine pi t, and then how are you able to like whether a polynomial function is able to approximate that or not. Okay, this is what the concept is, like the polynomial approximation. And this the concept that we are taking help is what from that starting one that I told you, right? If you are solving some equation x equals to b, okay, and if like in the column space of a that b doesn't lie, okay, then what will you do? You'll find the best up like the closest point, okay, that is the closest point from the column space of a, right? This is what generally you do. So here also we'll be using the same concept. So the same concept we'll be using. Okay, in the at the end of the day, what we are getting the solution as this part, right? So the solution that we'll be getting is whatever the vector that you have or the signal that you have. You'll what will you do? You'll just do the inner dot product with all the vectors that are there in the span. Okay, so let's for example here there were three functions, right? T5, TQ, and T, right? We were having three functions, right? And this is what this is basically one, the the mixed up, right? The span you can just think of as the three function T, TQ, and T5, right? The combination of all these three vectors. Okay, interchangeably I'm saying sometimes vector or signal, you can just think of as both as same. Like it's not same, but you can just think of for solving the problem you can just think of as the same, right? So T5, T3, and T, right? The combination of all these three signals or a vector, right? Now in the end what will you do if you have to find, right? So basically you can be asked to calculate what you can be asked to calculate ABC, the values, that is this type of problem can be asked to calculate. So what will you do? You have this formula, so every time you'll be using the same formula to calculate. You'll be using whatever the signal that has been given to you, that you have to best approximate. So that signal will do the inner dot product with all of the span, like all of the signals that has been given. So here it was given as T, TQ, and T5, right? So three signal has been given to you. Okay, so you can just think of as U1 as T, U2 as T, T3, or T5, right? The other one, the same thing you were doing in the starting weeks also you're doing the same thing. So you were given some span, right? You were span the vector, you were given three four vectors have been given to you, or this like three four vectors has been given to you, and then you were asked to calculate the values that are very close, that the most closest point that were asked to calculate, and you were using the same formula. So here also you'll be doing the same thing. Okay, only the problem here is in spite of vector you have now signal, and for each signal you have some formula, different formula. So here there the inner product was pretty simple. Okay, there is not that difficult like formula. Here you have to calculate the inner product also, you have some formula, integration of some time limit, and then x times y bar, something you have. So each time you'll have to use that formula. Okay, and one more thing, so u1 u2 u3 that you're working on, so whatever the signal that has been given to you, that you can't use directly. What you have to do is you have to take, like you have to calculate the first step should be to calculate the orthonormal of that. Okay, and then you have to use that value. Are you getting me or not? Are you able to understand that what you like what I was trying to say?
Sir, can we have an example for this
Yes,
for
Okay,
sir.
better
okay,
clarification?
okay. Let's have an example. Let's for example, you were having TQ T5, right? The span of this, and then what you have to do, you have to check whether to best approximate this vector or the signal, right? Sine of pi t, that is belongs to a function space of L2 from -1 to 1. Okay, how do you calculate this W star? How did you do? You will use this sine pi t inner product with u1, the span, each of the value in the span, each of the vector you can just think of as v1 v2 v3, v1 v2 v3. From v1 v2 v3 you have to get u1 u2 u3. That is the orthonormal basis. Okay, this you have to calculate. So here it has been calculated with the help of the Gram-Smith method, u1 u2 u3. Okay, and from that u1 u2 u3, now you have got the u1 u2 u3 that you have to use here. So v1 inner product with u1 in the direction of u1, then with u2 in the direction of u2, and then u3 in the direction of u3. This is a bit complex, like a bit complex. Mostly it will not be asked, but even if you have been asked, it will be asked very simple question, not that difficult question. Have you understood the method or not? If you will be asked to calculate, whether you'll be able to calculate or not, which polynomial will be best approximated this sine of pi t, how will you calculate? You have to use this formula, right? You have to use whatever the approximate, like whatever the signal that has been given to you. Let's for example here sine pi of t has been given to you, and then you have been asked whether this the combination of this t tq t5, okay, which combination, what are the values of abc such that this will start approximating sine of pi t in the limit of -1 to 1. Okay, for that what you are doing, you are using this concept. The concept is pretty same whatever we were using earlier. Now here what we are trying to do is whatever the vector that or the signal that has been given, sine of pi t, so sine of pi t dot product, inner product, not the dot product, inner product with the u1 in the direction of u1 plus sine of pi t in the direction of u2. Okay, similarly sine pi t u3 in the direction of u3. Okay, or have you got any have you understood or not?
Sort of,
Can
sir.
somebody oh, okay, yeah, so this is a bit challenging, like but mostly the problem won't be asked from this concept, because this, why? Because it becomes very difficult. First of all, the signal that has been given to you, first you have to use a Gram-Smith method and then calculate the orthonormal basis, and then from there you because that value u1 u2 u3 you have to use it, okay, to best approximate to the given signal. Okay, so this is a bit tedious, like a method that can take a lot of time to solve. So if you are able to see this problem, you can just solve it in the end.
Yes, sir.
Yeah, sir. Fine.
Yeah. See, like for example, a function t square has been given, okay, and then degree of degree one approximation, so a plus b of t. Now you have to calculate a of bt. So this you can just think of as one vector v1 as 1 and vector v2 as t, right? And then from here you have to calculate u1 u2. Okay, first you will have to calculate u1 u2 from the Gram-Smith method, and then what you have to do is t square, it should approximate t square. This is the function. So what will be the value? T square, the inner product of t square with what? u1 in the direction of u1 plus the inner product of t square with u2, okay, in the direction of u2. Okay, that value from here you will get some value of a and b. Okay, the a times the constant and b times t. So a, this will be the a, this function will best approximate t square in the interval of 0 to 1. Have you understood this or not? So here what you are asked, find the following polynomial approximation, whether a polynomial of degree 1 will approximate t square in the interval of 0 to 1. Okay, for that what will be the value of a and b? So that a and b you have to calculate. And how do you have to calculate? The same the method, w star equals to what? What is the value? V
V
times the
like
signal
1.
times v1, correct, in the direction of u1 plus v inner product of u2 in the direction of u2. Okay, and this u1 u2 you have to calculate from where? The Gram-Smith method for the given vector. Whatever. So here it was 1 and t. So from here you'll get u1 u2, and that u1 u2 you can use it in the inner dot product. I hope this has made sense, right? Somewhat. Okay, so if that has made so, and now the same concept will be keep on repeating. So now what you have to do, so till now we were dealing with the polynomial. So any function has been given to you, okay, any t, like here it was you have to approximate any polynomial with t square in the interval of 0 to 1. Now the Fourier series will come. This Fourier series, what you have to do is you have to take the span of this. So here we were taking what? So v1 we were taking a polynomial, right? 1 t square t q something like that. So now we'll start using sinusoidal values, right? Cos of 2 pi to cos of 4 pi t. So this is what? Now this is your, so span of this, the combination of this should approximate some function that has been given to you. Let's for example here the function that has been given here is, yeah, so let's for example xt, a function has been given to you xt, right? A function is xt is, that is in function space of L2, okay, from 0 to 1. Now what you have to do is you have to tell that this, the combination of this, the span of this sinusoidal values that has been given to you, 1 of root 1 comma root 2 cos 2 pi t, this, okay, how does, like how does this approximate this function xt belongs to L2 of 0 to 1? So the same method you'll be using. What is that method? You'll be using the same. So xt, inner product of xt times what? The
The
function u1
orthonormal
in the
basis.
direction of u1 plus, yeah, correct. So
X
xt,
of P with the orthonormal basis. Inner product with the orthonormal
correct,
basis.
correct. So
Yeah.
the same thing we'll be using here. But here our u1 u2, so u1 we have already got, right? So these are what? These are the sinusoidal. See, we have already been given, right? So now from here, from 1 comma cos of 2 pi t, cos of 4 pi t, okay, these are what you can just think of as v1, v2, v3, v4, v4, 5, something like that. And now from v1 you have to get what? u1, u2, using the Gram-Smith method, right? Orthonormal basis, that you can just, you have to make it this as orthonormal, right? And how do you do that? You already know that.
Yes, sir.
Okay, that method you'll use. And see, now we have used that method, we got what you got. So that when you
Orthonormal.
convert it, yeah, correct. So first is 1 itself, like, or the second one becomes root 2 of cos 2 pi t.
Sir, we have to find a norm of this first.
Norm of,
Norm of this vector, sir.
oh yeah, you have to make it as orthonormal. Yeah.
Yes, sir.
See, earlier, okay, so see, for the sinusoidal, see, the best part is this is all things, whatever the span of all those sinusoidal, that signal that you are using, these are already orthogonal to each other. So now as these are already orthogonal to each other, you just have to make it as orthonormal. And to make it from orthogonal to go to orthonormal, you just have to divide with what? You
Norm,
have to
sir.
make, yeah, correct. Yeah, so here because this sinusoidal curve, or the signal that you were having, or the vector that you were having, each vector is are perpendicular or orthogonal to each other. So now without even using the Gram-Smith method, directly from orthogonal you reach out to orthonormal. And now this can work as u1 u2 u3 u4, right? Directly you can use in that formula to get the best to calculate the best approximation for any function or any signal. I hope that is making sense. So see, and this is what a Fourier series is. If you'll just check it, see, if we were having some function xt, right? That was in the form of function space of L2 from 0 to 1. And now you have to project onto what? This, the span of this, right? And that's this 1 root of 2 cos 2 pi to root of 2 cos 4 pi t, from where we got, right? You can see that, right? From here only we got. So orthogonal, we were having all the combination span of all the vector in the form of sinusoidal. You have just gone from orthogonal to orthonormal, right? So
Yes,
the
sir.
similar, yeah. So this is what we got. Okay, and now see, you can see the projection. The same formula we are using xt I told you x of
Yeah.
dot product with what 1 in the direction of 1 first, and then x of dot inner dot product with cos of 2 pi t in the direction of what, the same cos 2 pi t. But here it was what, root 2 and root 2. That will make it 2, right? So here
Yes.
also 2, 2, 2, right? So this is the Fourier series only, right? If you'll see later in the later part, you can see that in the later part. See, this is what the Fourier series is. A naught, a naught is what? A naught is what? A naught, you can see that. A naught is
This-
what? X times inner product of 1, right?
Yes.
This is what A naught is, right? A naught you can directly calculate X times. So this is what inner product. If you have to calculate inner product of X and X dot 1, how do you calculate? X
Integration.
times YT. YT is what? 1. So 0 to 1 integration 0 to 1. So this is what your X A naught is. Similarly, you can calculate each of the value A1, A2, A3, A4. Or if this was the concept behind that, or you can directly like memorize the formula itself, okay? Because in the exam also will be given, if you have been asked to calculate the Fourier series, the all the expansion will be given to you. You have to calculate what, the coefficient only. So for the coefficient you can just remember the how to calculate the coefficient. For a naught you can just directly remember from if it has been given from some time period 0 to t xt dt, right? Similarly you can calculate for the coefficient. Mostly you'll be asked to calculate the a naught, a1 only, or b1. Okay, these three will be asked to calculate. If you are not able to understand the concept behind that also, that is totally fine, but you should be knowing the values, how to calculate the a naught, a1 and b1. That formula you should be knowing. Is everyone there? Are you able to understand this?
Yes, sir.
Okay, so I hope, yeah, so this type of problem can be given to you. You'll have to calculate the Fourier series, or so mostly the expansion will be given to you. You'll have to calculate the a naught, a1, ab1. I hope the formula, whatever the formula that is there, in the end, the formula, the main formula is there. That you should be knowing, and that will help you to calculate everything. So the same thing here, we were just dealing with 0 to 1. Here it has made to 0 to t. So the same thing will happen wherever the integration was from 0 to 1. Now the integration will be from 0 to t. You can see that, and maybe yeah. So you can see everywhere the same thing. So here the integration is from 0 to t, 1 upon t. Uh, So the formula you should be remembering. So a naught formula a1 and like al or ak you can just think of, and bk. This three formula you must be knowing. Okay, without this you'll be like maybe because there are some problem, one or two problem from this Fourier series. You must be you'll be able to solve that. The x value, this signal will pretty simple there. You just have to calculate a naught, b naught, and many a times it becomes zero. So many a times a naught becomes zero or b naught becomes zero because of the odd or the even condition that you'll be getting in the exam. Is it making sense, or it just went over your head? Are able everyone are there? Are you able to understand this? The
So,
reason? Yeah, yeah.
if the limit is not even, so that is like it is from 0 to 3 or some 0 to 5. So like basically, is there any way through which we can get the idea about it, that it should be somewhat like this?
Somewhat like this mean?
I mean,
See, let's.
by looking at the solution only, can we try, like, can we get some is there any thing like any idea or something, any trick?
Okay, see, if I'm giving you one question, let's for example, the function is given xt. For t is from 0 to 0.5, and this is 0 from 0.5 to 1. Now you have to calculate the Fourier series. You have to calculate the a naught. How will you calculate a naught?
It's 1 by t integration from 0 to 4, 0 to
1
1.
by 1 integration
0 to 1.
0 to 1.
So basically from 0 to 0.54 times dt.
So basically 0 to 0.5 only.
4 dt. Yes, sir.
So, and similarly you can calculate a naught also, an or bn, like a1. You can be asked regarding the an, bn. Those type of things can be asked to calculate. I hope this is not be a difficult task for you now.
Yes, sir.
Okay. So any other doubts that you have from 11th week? So I told you the question that most probably will be asked from this week will be regarding the Fourier series. In the Fourier series, will be asked mostly will be asked regarding to calculate the A naught formula. You should be knowing. Okay, if you don't like, even though you know the concept behind that, you should be knowing the A naught formula or AN and BN formula. If you are knowing this three, you'll be able to solve the problem. Okay, this much you should be knowing. Or the second concept that should be knowing from the 11th week is, so 11th, the second thing that you should be knowing is whether the sequence space that has been given belongs to L2 or not, or the function space that belongs to L2 or not. And the third thing is the norm to calculate whether it belongs to L2 or L2 or not, the sequence space and the function space. The next part is what you should be knowing to calculate the inner dot product. The formula should be knowing xt yt ka bar. Okay, or you should be knowing the to calculate the norm ka square. Okay, that is what whole square 0 to 1 0 to t dt. Clear? This
Yes, sir.
5 6 concept we should be knowing. If you are able to know this, you will be solving all the questions from at least this week. There won't be any, you won't face any problem in this week. Okay, let's move to the next part now. Any doubt that you have? No, right?
No, sir.
Okay, you have solved the mock roll, right? So mock also, I don't think so there is any question apart from this topic, right? So mock
Yes.
also you have given two signals and then you have to find whether it belongs to L2 or not. Okay,
Yes, sir.
yeah,
Just in a product and norms and all.
correct. So similar question will be asked, and Fourier series for sure will be there. So you should be remembering the formula for sure. Okay, formula you must be knowing A naught, or maybe try it out one or two questions. Okay, from anywhere you can just try it out, just skibble, so that you should not be using the different formula, or the formula you should not be, because if you will just change the formula, you'll get the different value. Okay, now let's move to the next part, the circulant matrix. Okay, for the circulant matrix, I'll just go. So I have something, I just wrote it out. Yeah. So for circulant matrix, you whatever the matrix that has been given to you, mostly you'll be asked to calculate the lambda naught, or the best part is you can directly calculate the one vector, the eigen value you can directly calculate, right? There won't be any problem in calculating one vector, one eigen value, right? Even one eigen vector also there won't be any problem in calculating that, correct? You
Yes,
can
sir.
directly do the summation of that, you'll get it.
What?
Similarly, the formula you already have for the eigenvector or eigenvector
Actually,
also.
excuse
Yeah.
me, sir.
Hmm.
Since many of us are facing this issue, like if we have a circulant matrix, how are we supposed to calculate the eigenvalues and eigenvectors? That is
Yeah.
one of the major issues everybody
Yes,
is
sir. We
facing.
are facing the same.
So there's a formula, right? That you use it to calculate, right?
Can you please explain it through an example?
Okay, okay. Let me check whether I have any example.
Or we can even go with the question we have in the mock.
Okay, mock we have a question. Okay, let me open that. Okay, so the mock question is, so this one, right? -1 0 1 0, correct?
Yes, sir.
Right. Okay. So if you'll just write it, the circulant matrix will be what? -1 0 1 0 -1 0 1 0 1 0 -1 0 0 1 0 -1. Correct?
Yes, sir.
Okay. So what is the one lambda will be 0. Lambda 0 is 0. Correct?
Yes, sir.
V 0 is 1 1 1 1. But the lambda 1, what is the formula for lambda 1?
So, H0 plus
H0 plus.
plus hn minus 1 times e to the power I.
Okay, this is basically summation of what? J equals to 0 to 3, right? You have four values.
Yes, sir.
Hj,
Omega to the power k to the power j.
right? So you have done with 1. So now, so lambda 1 will be, okay, I'll just write the summation itself. H0 times minus 1,
To the power 0
correct?
plus h1 times omega power minus 1. No, sir, 1, sir. Power
Hmm.
h2 times omega to the power 2. Yes, times omega power 3.
Now what is the value that you are getting?
H naught is 1, sir.
So H naught is minus 1, right?
Minus 1. So minus 1 plus, so 0. H1 is 0.
H1 is 0. Even H3 is also 0, right? H3 is also
Yes,
0. So H2 is what?
1, sir.
H2 is 1.
Times omega to the power 2 minus 2
Right. So this is the value, right? Omega
to the power minus 2.
minus 2. 4. So this is what? This is 1, right?
Yes, sir.
So you'll be having what? 1 or minus 1, I guess. This is minus 1.
No, sir, it is not minus 1. E to the power some 2 pi by 3.
E to the power minus 2 pi
By 3, sir.
k by 4, right? Not 3.
Yes, sir. 4. Iota, is, I think, is.
Yeah, so this is minus 1, right?
Yes, sir, correct.
So this will be minus 1, minus 2, right? So lambda 1 is minus. Similarly, you can calculate lambda 2. Yeah, this is a bit. So here, though, you have already. So you are left with only. Because H1 and H3 is 0. So you are left with just minus 1. And then,
Omega to the power 4
yeah,
is 1.
plus is 2 times omega
To the
minus
power
2
to
square,
the power.
correct?
Yes, sir.
This will also be, so this is 1. So this will be 0, right? Minus 1 plus 1.
Yes, sir.
H3, similarly, you can calculate.
Minus 1 plus h,
This is also minus 1.
h2 to the power 6, sir. Omega to the power 6 minus
Yeah,
6.
so again, yeah, so minus 1, minus 2.
Minus 2.
So left with minus 2, 0, 0.
Yes, sir.
Okay. Hmm. So now you can calculate eigen for eigenvector also. So there is like vk you can calculate, right? How is that? 1 upon root of 4, 1,
Omega power.
correct? So
Yes.
for v0 you have already got v1, v2, v3. You can put it all the values you can get, right?
Yes, sir.
Yeah. Any doubt? Anyone? This? Anyone is have any doubt in this? No, right?
So for
Okay.
this type of question, we have first we have to find omega, then simplify.
Hmm. See, circulant matrix, which type of problem you can be. Whatever I'm telling you, you should be knowing that much for sure, right? You will be given a circulant matrix, or maybe a column, and then you have to create the circulant matrix. So you'll be able to create it, right? You just uh, like rotate it in. okay, maybe row wise or column wise, you'll get the circulant matrix. Okay, and then mostly it will be in the form of options. If so, the option, if you have been given some eigenvalues or eigenvector will be given to you, correct? Right?
Yes, sir.
How will you do that? See, if you have a matrix, right? A times,
UK is equal to some lambda times UK, sir.
yeah. So eigenvector, if have been given to you, you just multiply it. If just thinking that it will take a lot of time, you multiply this AV. If you are getting, so here lambda times V you should be getting, right? So from there you'll get an idea.
So lambda is the corresponding value of lambda vectors.
Yeah, this is the corresponding value of your eigenvalue, right?
Yes, sir.
Correspond. Okay, so in the option, if you have been given the form of option, mostly it will be in the form of options only. Four options will be given. If they are asking eigenvector, what you can do is you can just try it out. Av, you'll get an idea whether V that you are getting is in the form of some scalar value or not. If that is not, like in any random V it has been given in the option, if you'll just multiply it, you'll get an idea, right? Whatever V it is, if you're not reflecting in the form of a scalar value, you can directly reject this V. Are you getting me?
Yes,
See,
sir.
if you are multiplying A times B, whatever the matrix that has been given to you, and times V, okay, that is not that difficult to multiply. And if you are getting in the form, let's for example 3V, then you can get an idea, right? That okay, this can be, so this is a eigenvector corresponding to lambda equals to 3, right? And if let's for example you are not getting this, whatever you are getting, this is not in the form of a V, then you can directly reject this V, right? This can't be eigenvector for sure, because whenever you multiply A times B, this whatever the right side should must be getting something in the form of this, right? Then only this will be eigenvector.
So the lambda can be any real number, sir.
Lambda can be any values.
Okay, sir. It may it will be some complex number also.
So mostly it will not be given in the form of a complex. Yeah, it can be in the form of a complex. Yeah, it can be in the form of a complex also.
Okay, sir.
Okay. So the first thing is, if in the circular matrix one eigenvalue you can, or one, or yeah, so this will take a time, like at least some time it will take. If you have the formula, remember the formula, you'll be able to calculate it, right? See, from, if I am not wrong, this is the method, right, to calculate this. All things you should be knowing. These are all very basic things. Okay, and one more thing, for the circular matrix, the basis that you are getting, that you have calculated u1 v, all the eigenvectors that you have got it, right? So eigenvector, that you can see that the properties here. So the norm is what, 1. So actually you are getting whatever the eigenvector that you have got. Okay, that is in the form of what, orthonormal. So the each of the vector is having a unit length and are perpendicular to each other. So you can see that, right? Even though the values, the eigen values that you are getting is not real always. So for the symmetric matrix, what happens? You'll get always the eigen values as real, right? And then you are getting the orthonormal or orthogonal, and then you make it as orthonormal. But here, what is happening? Even though you have dealing with the circular matrix, but whatever the vector or whatever the eigenvector that you are getting in the form of a orthonormal, right? So each of them is perpendicular to each other. You can see it from the proof also, and the unit length is also 1. Okay, even though this is not a symmetric matrix, correct? Even though the eigenvalues is also can be in the form of a complex, but the vector that you are getting is in the form of orthonormal. Okay, that's the best part about the circulant matrix.
Yes, sir.
I hope this is clear. Okay, so this much you should be knowing for a circular matrix, and this will be asked in the exam. For the given circular matrix, calculate the eigenvalue and eigenvector. So practice 1 or 2 questions. Maybe the mock question you can practice once again. Okay, this will be asked in the exam. And the next part that will be asked in the exam from the DFT is, so this concept, okay, whether the diagonalized form, okay, whether you are able to write any matrix M in the form of this or not. And if you are able to write, then tell me the diagonal matrix. Okay, for the diagonal matrix, again you have to, what you have to do, you have to calculate the eigen values. If you are able to calculate the eigen values, you will be able to calculate the diagonal matrix also. So in any case, you will be mostly asked for the circulant from this topic. You will be asked to calculate the diagonal matrix, or you will be asked to calculate eigenvector or eigenvalues. For every cases, you must be knowing how to calculate the eigenvalues and eigenvector. Okay, so you should be practicing. If you have one more day, at least practice this for any circular matrix, how to calculate the eigenvalues, eigenvector. Okay, that's two formula you have. At least write 2-3 times. Okay, that'll be more than sufficient. Okay, if you have been asked to calculate the DFT, that matrix, what will you do? You just have to calculate the eigenvectors itself. If you have been asked to calculate that eigen matrix, again you have to calculate the eigenvalues. Clear? Okay, is it clear to everyone? Okay, or the next part, what you can be asked to calculate is what? This value, the capital H, the coordinate of small h in the Fourier basis. Okay, how will you calculate that? Whatever the matrix, the DFT that you have times h. Are you there? Anyone is there, or you are not able to speak?
Yes, sir. Yes, sir.
Yes, sir, yeah, I think.
Okay. So if you have been asked to calculate the coordinate of a small h in the Fourier basis, how will you do that? This is the
Inner
from the,
product.
yeah,
This.
correct. And this is what? This is the lambda value. Okay, you can calculate hk in the form of lambda k upon root n also. This also you can use it. If you have been asked to calculate the coordinate of a small h or the capital, it will be written. If you have been asked to calculate this, what will you do? The lambda, if you have the lambda k, just divide with the root of n. Or
Yes, sir.
if you have the hk also, from there also you can calculate lambda k. So this is an important thing that you must be knowing. This is also very important that you should be knowing. So from this week, this will be asked. Mostly this will be asked. You will be given the circulant matrix to calculate eigenvalue, eigenvector, or maybe you will be given the matrix whether you will be able to write it in the form of DFT, Hermitian times of diagonal, or if you are able to write it, what is the diagonal matrix? To calculate the diagonal matrix also, you should be knowing how to calculate the eigenvalues. Okay, and to calculate that Fourier basis, you should be knowing what, how to calculate the eigenvector. So at the end of the day, you should be knowing how to calculate eigenvector and eigenvalues. If you are able to know that, you'll be able to solve the problem from this week. I hope this is making sense.
Yes, sir.
Okay. Okay. So this week, mostly this will be asked. Okay, in the exam, not much, not less. Yeah. Now from the ninth week, what will be asked? So what did I say? From the ninth week, the graph theory is the most important part. Okay. If you have been given a graph, how to write the adjacency matrix? Everybody knows that, right? How to write the adjacency matrix, correct? So you can see that 1 2 3 4, 1 2 3 4. This is 1 2 3 4. Okay. Is there any root from 1 to 1? No, right? So that's why 0. Is there any root from 1 to 2? Yeah, 1 to 2 you can
Yes.
go. So that's why 1. Similarly, you can write it the whole matrix. This is what? Adjacency matrix. This is what you called it as adjacency matrix. Okay, this is what A. Okay, A means what? A to the power k is equals to 1. That means what? With one hope, with only direct connection. With how? What is the number that you can go it from 1 to 2? So there is only one
Number of
direction.
roots.
One direction, I mean only one path
Yes, sir.
from
Number.
1 to 2. Okay, if it was, let's for example, it is a square. A square is this. Okay, that means what? You can go from 1 to 1. You can go from 1 to 1 in how many
Two steps.
paths? Two paths, right? Number of paths is what? 2.
Two.
Okay, similarly, if you can go from 1 to 2 or 1 to 3 or 1 to 2 with two hope. Matlab,
Steps, sir.
like
Sir. It's two
that
steps.
number. What?
Number of steps, sir, from
Correct, correct. Yeah, hope. Yeah, number of steps you can just understand. The number of steps should be 2. Okay, a square means the number of step is 2, and what is the number of direct, like how many paths are there? One path
Yes, sir.
with two hope, or two hope, I mean two junction, like Delhi to Chennai, and Chennai, like if you have to go from Delhi to Patna, uh, not Delhi to Patna, let's for example you have to go from Delhi to Chennai. Okay, so you are going, the first stop is Delhi to Kolkata, and then Kolkata to let's for example Chennai. So you
Yes.
have a two junction, right? So one junction in between, and then you are reaching out to Chennai, right? So this is what trying to say. A2 means that only two hope, right? So from uh, I hope this is clear, right?
Yes, sir.
Similarly for AQ, what in between two junction, so altogether three. Okay, so let's for example A3. I don't know whether for this is for which example. I guess this is for this example only. This is a graph that has been given to you. Okay, for that A is what? This simple adjacency matrix. For A square, this is what? AQ. Okay, AQ means what?
To reach the point in 3 steps from the point.
Correct, correct. See, let's for example, from this is 1, 2, 3, 4, 1, 2, 3, 4. So from
From
1
which
to 2, from 1 to 2, if you are just
we
going
are
from 1 to
going.
2, there are 4 paths.
Yes.
Okay, and with 3 hope, like in between 2 junction.
Yes.
Yeah, this is what it means. So here also you have mostly not be asked, but basically see this type of problem, the graph theory can be asked like some sort of a in the options wise, like a, what do you mean by a square? So the statement will be given and then you have to choose out which of them is correct. Okay, this type of problem can be asked from the graph theory. The most important thing that will be asked from the graph theory is whether the given so you can be given the adjacency matrix and then you have to find which of the following graph it represents from the adjacency matrix. Okay, that you should be knowing for sure. I hope this is pretty simple. That is very simple. To from graph, you have to reach out from the adjacency matrix to the graph. You just check out. Let's for example for this, you just check out. Okay, from 1 to 2 there is a graph. Just check out 1 to 2. There should be a graph. There should be a path in the graph also. Okay, this is how you choose out. So for the given adjacency matrix, you have to choose out the graph, or maybe the graph will be given, and then you have to choose out which of them is the adjacency matrix corresponding to that graph, given graph. Okay, the next part that will be asked to you is for a given graph whether or for a given matrix whether you are able to whether this graph is a bipartite or not. Okay, how do you check that? How do you check whether the graph is a bipartite or not? You check the, you calculate what eigenvalues, right? And if the eigenvalues in the form of, if let's for example you have eigenvalues as 2, then minus 2 should also be there. For any non-negative value that is present as an eigenvalue, the other part, the conjugate part, not the conjugate part, the other part should be there. For 2, minus 2 should be there. For 3, minus 3 should be there.
Yes, sir.
Correct? So this is how you check. So you can see that for any non-zero eigenvalues lambda of a graph, minus lambda should be present. If this is happening, okay, for all non-zero eigenvalues, then you can say that this graph is a bipartite. Okay, and this I'm reiterating it again and again, and this will be asked in your exam also. Okay, so you should be knowing these properties. I hope this is making sense to you. So from this week, this is the most important portion that you should be knowing. Okay, the positive definite and positive definite and all, you can be given a graph and then you have to check whether it's a positive definite, semi definite or not. Not positive definite, that is a different concept. Positive semi definite. For positive definite, everything should be greater than only 0. For semi definite, everything, all the lambda should be greater than equals to 0. Okay, for a given graph or for a given matrix, you will be asked whether it's a positive semi definite matrix or not. How will you check? You calculate the lambda or the eigenvalues. Each of the eigenvalues should be greater than equals to, some can be 0 also, but none of them should be negative.
Negative.
Okay,
Yes.
is it clear?
Yes, sir. Yes, sir. Okay.
Each for each of the symmetric matrix, each of the yeah, this, or you can say that the energy stored or the energy concept is not been taught. You should be knowing that each of the lambdas should be greater than equals to 0. Some should be 0 or some can, yeah, Vivek, you are asking something.
Yeah, yes, sir. Actually, I have two doubts.
Yeah, yeah, go ahead.
Yes, I'll just tell you the question number. Just a second, please.
Hmm. So from
Yeah,
this
sir.
week
So
you must be knowing this.
yeah,
Yeah.
sir. So first one is the activity question 11.4, question number 2.
Okay, let me open that. Just give me a time. Yeah, question number, can you tell me the activity?
Yeah, sir. Activity 11.4 and question number 2.
Yeah, what will be the degree 1 approximation? This is what you have asked.
Yeah, yes, sir.
Okay, So the same thing, right? How will you solve this? See, for a degree 1 approximation,
To find the orthonormal basis.
correct. So the same thing you have to do here also. You have been given a t square, right? T square is xt, that belongs to x2 equals to t square, that belongs to
L2.
0 to 1. Correct. Now to degree 1 approximation, how will you write? A plus
T
bt,
plus.
correct? So
Yes.
what is that v1? You can just think of as v1 and 2. Just write u1 u2, correct? And then what do? Xt dot product, inner dot product with u1 in the direction of u1 plus
Plus x of t
xt
dot the product with u2 in the
u2
direction
in
of
the
u2.
direction of u2. You just calculate this, you'll get that. Okay. Yeah. In next question.
Yes, sir. Just a second. I'll tell you the question number.
Huh. I hope, yeah. So ninth week, I told you the graph theory you must be knowing and the positive semi-definiteness. Okay, that you should be knowing. Without that, please revise those concepts for sure. Okay, 10th week, I told you the DFT concept, right? You must be knowing if you have been given the DFT, multiply with the small h to get the capital H, or the formula that the simple formulas were there, lambda upon root of n. If you have the lambda, you can calculate the 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 the, the values or the coordinate in the frequency domain. Okay, if you have been given the time domain, that thing, the capital H with the small h, that you call it. Or the next concept that I told you is from the last week, the 11th week. 11th week has a good chunk of questions, like some at least the 10 marks from the 50 marks. Okay, so you should be knowing whatever I said. Okay, you should be knowing whether the given function belongs to L2 sequence space or not, function space or not. Okay, how to calculate the inner product, how to calculate the norm of that. Okay, that you should be knowing. And then at the end of the Fourier series formula, a naught, a n, b n, that you should be knowing. Okay, without that, like, please revise that. Well, you have one more day, just revise it. If you have a doubt, you can just ping me on the discourse, or maybe you have the group, right? So there you also ping me.
Okay, sir. Sir, the second question is the mock question number 5.
More question number 5. More question number 5 is, so you have been considered EFT with H has been given, right? Okay. So H is given, H naught, H3, capital H been given 2, 0 minus 2, 0 in the frequency domain. Now you have to calculate H naught. Okay. So what is the formula for H naught? H capital H.
Sir, lambda k by root n.
Okay, lambda k by root n, that is fine. But that you can't calculate the
Inner
lambda.
product, inner product of h into the orthonormal base. Okay.
No, see, there is one more formula. Lambda, how do you write? If you'll just expand this, how will you expand this? There's a see expansion, you can just see there. Hmm. See, this is there, right? This is lambda. This is right. This is lambda. Correct. Okay. Now H1. H1 has been given. H1 is what? H naught. Sorry, H naught. All the information has been given to you. H naught is given as 2. H1 also. H2 also. H3. So they have given as 2, 0, minus 2, 0. Correct.
Yes, sir.
Hmm. Hmm. What do you have to calculate here? What do you have to calculate? Find the value of the summation of. Okay, you have to calculate the summation of h naught h1. Okay, okay, got it, got it. See, what is the lambda h? H naught is 2. If you have to calculate lambda 1, lambda is what? Can you tell me the lambda? Root of n times what?
H
H
out.
naught. Correct. So root of n, how many? 2 times 2. This is 4, right?
Yes, sir.
Correct. Or lambda naught is what? H1 plus H2 plus H3 plus H4.
No, sir.
What?
So lambda naught is not. How, sir? Is correct, sir.
This is fine, right? This is how what happened, right? Lambda is what? See, what is the value of lambda? Lambda naught is what? You just do it summation H1,
About.
H2, H3, H4. Correct?
Yes, sir. Circle matrix.
Correct?
Yes, sir.
So this is what? This is lambda. Lambda naught. So from lambda naught, H naught is given. H naught is what? H naught, you have the formula H naught upon root of n. Correct?
Yes, sir.
Okay. So H
Root
naught is what? H naught is 2 times root of n is what? Root of n is
4.
4.
Root of 4,
So
sir.
2 into 2, 4. So lambda naught equals to 4. That is what is H1 plus H2 plus H3 plus H4. So you have
Yes.
to, yeah, now this is the summation of 4. So this is what the value. Correct?
Yes, sir.
Yeah, the 4 should be the answer. Yeah. Any other doubt? Anybody has? So this 3 weeks you should go and just at least go through the slide also once. Okay. If you want, so whatever I written here, that is the most important part. You should be knowing. Okay. If you want this PDF, I can give you. Okay. So this you should be knowing for the week 10 and week 11. Yeah, Vivek, you have any other doubt? Anybody has any other doubt?
No, sir. Thank you so much for the solutions.
Okay.
Sir,
Anybody has any other doubt?
my doubt is that when a matrix is diagonalizable, if matrix is 3 by 3 matrix and it
Hmm.
has three, not three eigenvalues are different, sir.
If the not eigen, okay. See, first condition is what? All the values, all the eigenvalues is different. Then you can directly say. If all the some of them are repeated, then you have to check the algebraic multiplicity, whether the algebraic multiplicity and the geometric multiplicity are same or not. Okay, that's the only the two condition that you can check it.
So if all eigenvalues are different, then we directly say that it is
Yeah,
diagonal.
yeah. Huh.
Yes, sir. But if any two of them are equal, then we will
Then
check.
you have to check the multiplicity. Yeah, but those type of problem can be asked, but very less likely because if that would have been asked in the starting week itself. Now, because most of the problem I told you from the last 3 weeks. Okay, so and the starting weeks will be having a very basic question. Okay, so don't worry about that. Okay.
Okay. Sir, in
Hmm.
quiz 2, there is one questions like that. So,
I know. So that is what I said. If that has to be asked, it would have been asked in the starting quiz 1 or quiz 2 itself, not in now. Now because there are so many other concepts in the last 3 weeks, so just go revise the last 3 weeks nicely. Starting weeks the problem are very basics, very
okay.
basic. I'm telling you. Yeah.
So can you explain once again algebraic multiplicity and geometric multiplicity, sir?
See,
Just so.
that was the okay. Any other doubt that you have from the last 3 weeks? I'll just go through 1 second. No, right? Okay, let's discuss then.